thing we're doing today is a review on some of the different properties and rules that we've been learning over the past few days. So if you could get to this page, or if you can see this, each of these 5 equations have something wrong with them. Because they have something wrong with them, I would like you to figure out what is wrong with them and then fix it. I'm going to pause while we work, but if you are struggling, I would suggest looking at the different properties that we've learned over the past few days and the different shortcuts we've been learning. So I would like to use our Christmas-themed Dice of Destiny, because they're red and green. And row 2, person 2, Isabel, can you tell me which one of these were you able to correct?
First one, corrected will be log of 5 of xy.
So this is a multiplication sign right there. Awesome. So we have log base 5 of x times y would get us log base 5 of x plus log base 5 of y, as the product property of logarithms says. Okay, would you like to call on somebody? Row 3, person 3. Look at all these doubles. That's you, John. Brian, sorry. Whoa.
John?
John. Wow.
You mixed me up with John Manning?
Maybe.
That's embarrassing. John is not a smart person.
That's so sad. It's because you guys sit in the same, your typical seats are the same seat. And I was like, wait, this is not, this is 3rd period. No, your typical seat. Your one up here.
Yeah, so I would have had an answer.
Oh, I'll answer.
Okay, nope, Ryan, you're gonna answer one of these for us.
Okay.
Which one would you like to choose?
I'll do number 3.
Okay.
Okay, I think it should be log x minus log y.
The left-hand side or the right-hand side?
Right.
Right-hand side is log of x minus log of y. Indeed. Okay. Would you like to call on somebody? Ryan? Okay, that's fine. Maybe I'll roll another double. Ah, so close. Row 2, person 1. Ryan. Can't do a log of 0, so how could we change this to make it true? We could say that this is a 13 instead. Another thing you could have done with this one is you could have changed where the 1 and the 0 were. Either of those options work. And would you like to call on somebody? Right. Okay. Row 5, person 3. Brady. 2 and 5 left.
Oh, 2 and 5 left?
Yes.
Then I take the right side of something and 3 go to the front.
For number 2?
Yeah.
Okay, so for number 2, we have this 3 would go to the front instead. Okay. So this should be 3 times log base 2 of x. Okay, I need somebody who thinks they know number 5. What do you think, Ava?
Okay, so on the left side, x minus 3 is log base 3, the r, or whatever is that.
So this 5 should be right here instead if we wanted to get 5x. That is correct. Another way we could look at this is, what if we said, or what if we assumed the right-hand side was wrong? Would you know what the right side would be instead? It would be x to the 5th power. Remember yesterday how we were talking about if we had something that was just 3 to the power of log base 3 of x, what could we do with this? What would our answer be? It would just be x, because our base here and our base here can just cancel out since they're the same. So we would end up with x. However, the problem with this is that we have a 5. So we have 3 to the power of 5 log base 3 of x. And that canceling only works if the bases are right next to each other, and they're not here. We have this 5 in the way. So if we have a 5 in the way, and we want to put the 5 somewhere else, we can use our power rule, which tells us if we had something that was like log base 2 times x to the second, our power rule told us that we could take this exponent and we could move it out in front. Or you could do the opposite way. So if you had 2 times log base 2 of x, and you wanted to put this 2 somewhere, you could take this 2 and you could put it back in the exponent. So over here, if we just take this 5 and we put it back in the exponent, we will end up with 3 to the power of log base 3 of x to the 5th. And now, since our 2 bases are right next to each other, we can cross it out, and all we're left with is just the x to the 5th. So that's 2 ways that you could have solved problem number 5 here. Okay, what I would like to do next is show of hands who here struggled with the inverse functions that we did yesterday. Okay, who here struggled with the material that we did the day before that had something like 1/2 to the x plus 7 is equal to 4 to the x minus 2, and we were solving for x. Who here struggled with that more? Okay, I'm not getting a lot of hands. So your 2 options are either the inverse functions or this one. Which one did you struggle with more? So take 5 seconds. Think about which one you struggled more with. Okay, who struggled more with the inverse functions? Who struggled more with stuff like this? Okay, we're going to start with inverse functions, and then we are going to continue on to problems like this to review. So, I would like to start off our inverse functions with the question I posed to you at the end of class yesterday to do for homework. So some of you got it. I didn't want to post it because we were going to go over it today anyways. But we had y is equal to 5 times the log of x minus 2. Is that correct? Okay. So if we look at this, we want to find the inverse function. And if we're finding the inverse function, actually, before we even find the inverse function, can we find something else first? Can we find the domain? If we are looking at our original function here, we're finding the domain, which means what values of x will not work? 0 and negative numbers will not work. So our domain would indeed be 0 to infinity. That would be our domain. What about our range? See, if I look at this, could I get a negative number for my y? Yeah. Could I get a positive number for my y? Probably. Definitely. Could I get 0 for my y? How would we have to get 0? This here would have to equal 2. Could we maybe find a way for that to get us 2? Probably. So if we can get negative numbers, and we can get positive numbers, and we can get 0, all reals, or just from negative infinity to positive infinity, is our range. Okay, now we're going to find the inverse function. What's the first step to finding the inverse function? Always, if you are finding an inverse function, first step, regardless of what your problem looks like, is to switch your x and your y. And now we just have to solve for y. So first we need our y term alone. Noreen, what do you think would be the best bet for our first step if you want the y term alone? I like it. If we add 2 to both sides, we end up with this. And remember yesterday how I said we should probably aim for getting the logarithm by itself? So what should we do next? What do you think, Emma? Let's divide by 5. So we will have x plus 2 divided by 5 is equal to the log of 5. Sorry, the log of y. I spoke there. And from here, it looks problematic because I wouldn't know what to do from here. Except, what if I just switched spots? So I just put the log of y first, and then I just put the x plus 2 over 5 on the other side. What form is that? That's logarithmic form. If we're in logarithmic form, what do you think will happen if we change this to exponential form? Okay. Switch this to logarithmic form. I'll pause for a few seconds. Please work. Now that we've checked a little bit, if we put this into exponential form, somebody who I have not heard from in a very long time. You all had the right answer. Just tell me what your answer was. How about Quinn? 10 to the power of x plus 2 over 5 equals y. My only question here is, where did the 10 come from? If you have a log and it has no base written down, that's because the base is actually 10. Awesome. Thanks for spotting that. Okay. Here's one more for you. And I should actually probably open up my notes instead of just thinking on my feet. I guess I could just think on my feet. Okay. Let's do... let me change one thing first. Let's make this y is equal to 5 times log base 4 of x minus 1. I would like you to find the domain and range first, and then I want you to find the inverse function. I'll pause to give you a few moments to work. Let's call on row 3, person 4. Caroline, what's our first step? Our first step, always. Do you want to do first step, or do you want to do domain or range?
Domain.
Okay. What do you think the domain is?
1.
1 to infinity. How did you get the 1?
Because I knew that, like, inside the thing there can't equal 0, and if you put a 1 in there, then I knew 0.
So this right here has to be greater than 0. So if you just solve that inequality, you got 1, and then it goes to infinity. Thank you. Would you like to call on someone to give us the range?
No.
Okay. Row 5, person 1. I haven't called on you yet today. It's like a new record.
For the first step, I can switch x1.
Okay. First step here, for our inverse function, we are switching x and y. Thank you. Okay, would you like to call on somebody? Someday. Row 4, person 5, would be, oh, there's Katie. Okay, you can either tell us the range or the next step. Either one.
For the next step,
you move this over here. Okay, that's a solid step. So we are left with log base 4 of y minus 1 to the 5th power. Okay? From here, we're in logarithmic form now, right? So if we just put this in exponential form, all of our problems will be solved. So if I want to put this into exponential form, can somebody help me out? Olivier, if we wanted to put this into exponential form. Okay, so here's our log is bay. So if we want exponential form, then we have, first we need a base. What will our base be? 4. And then we need it to some power. So what's our exponent? That's our argument. The other one, x, okay? And then that will equal our argument, which is y minus 1 to the 5th. Yes? We will talk about that. That is a very good observation. Okay. If I wanted to continue solving it out this way, if we were solving this out, if I wanted to get y alone, what would be my next step? What do you think, Caroline? Okay, so it's already to the 5th power, so we need to get it out. So this thing. So if it's to the power of 5, then you have to take the root of 5. What is that? The 5th root? I think that's what it's called. The 5th root. And so we'll have the 5th root of 4 to the power of x is equal to y minus 1. But how do we rewrite the 5th root as a power? I am hearing 1 over 5. So wouldn't that just be the same thing as if I said I have 4 to the x here, and that's to the 1/5? And since there's just a parentheses here, what can I do with those two exponents? Multiply them. So then I have 4 to the x over 5 as my power. And that's equal to y minus 1. And from here, all I have to do is just add 1 to both sides. That's a plus. So earlier there was a question about, well, at an earlier step here, for instance, this step right here, why didn't you just divide both sides by 5? For the people who divided both sides by 5, you ended up here with x over 5 is equal to log base 4 of y minus 1. And if we wanted to rewrite this in exponential form, you would have 4 to the x over 5 is equal to y minus 1. So did you end up with the same answer that we got down here? You can do it both ways. Whichever way is more comfortable for you. You can either divide out the 5, or you can move it up and then take the 5th root later. So these are the same. What was the what? It's a good question. What is the range? Who here thinks they know what the range is? Okay, let's think about it. If we have our original equation right here, can you get a negative y value? What if inside of my logarithm I had log base 4 of 1/2? What's log base 4 of 1/2? I don't know off the top of my head. However, I would tell you that's a negative number. If you don't believe me, pull out a calculator really quick. Might have a little bit of problems because you don't really have light to see your calculator screen. Unless you have one of those fancy new calculators that have their own light. Some of them glow in the dark. Those old ones do not. Let's see, if I wanted to just take, let's do log, even like log base 10. If I do log base 10, which is the regular logarithm here, and I take it on the inside, I say it's some fraction, 1/2, I'm going to end up with a negative number. If I do log of 2/5, I'm also going to end up with a negative number. If inside your logarithm, right here, you have something that is a fraction less than 1, what will come out of this will be a negative number. So all of this will be negative if this right here, if your x is less than 1. Can it be less than 0? In here, can we have something that's equal to 0? No. Can we have something less than 0? No, because we can't have a negative. So that means that it has to be, x has to be greater than 0, and it has to be less than 1. So if you have some kind of fraction that is less than 1, but greater than 0, you will end up with a negative for this logarithm, so you can get a negative y value. So you can have a negative y value. You can have a positive y value. You could also get 0. So our range here is negative infinity to infinity. Now, what if I asked, if we look at our new inverse function here, what's the domain and range of this? If I think about my domain, are there any x values here that would crash my function? No. So then my domain would just be all reals, or negative infinity to positive infinity. And then if we think about our range, if we look just at this, what's the smallest value you can get? Zero. Because if you take 4 to the 0th power, you get, would be 1. Can you even get 0? You can get infinitely close to 0, exactly. So you can't quite get to 0, but you can get infinitely close. And so you have something that's almost 0 plus 1. So this number here, your range would have to start at 1, and then it could be any number greater than 1. Except, even without thinking about what this could be, I already knew what the domain and the range were. Do you know why? If you have an inverse function, what was the domain and the range for my original function? If I look at my domain and my range, what happened to my domain and range when I looked at my inverse function? It just flipped. So if you are unsure about the domain or range for one of these types, either for the exponential or for the logarithmic, all you have to do is say, okay, well, I already know what the domain and range is for this. So if I'm taking the inverse of this, I'm just going to flip my domain and range, and there, I've got the domain and range for my inverse function. With that in mind, remember this one that we did up here? Our first example? Look at the domain and range. What's going to be the domain and range for our inverse function? Write it down on your iPad next to this problem. I'll give you a few moments. So we ended, or the last time before I paused this recording, I had asked to find the domain and range for the inverse function of this problem here. And so if we look, this is what the inverse function was, and we wanted the domain and the range. So could someone tell me what the domain was? Yeah, Quinn? The domain is all reals. And somebody can tell me what the range was? 1 to infinity? Close. 0 to infinity. And the way that we could easily find this without even having to look at our inverse function was, since we have the domain and the range of the original function, you just have to flip them and you'll find the domain and range of your inverse function. Okay. Wait, 39. Okay, so I would like to do one problem similar to something else that we talked about yesterday. Let's go with, oh, this is going to stretch. Yeah, let's go with this. I don't know if this is going to crash horribly or whether it's going to turn out swell. So we're just going to go with it. I would like you to simplify this as much as possible. Simplify this as much as, simplify. No, you don't have to find the inverse. There's no x to find the inverse with. Just simplify this. I'll pause. I would like person 1, which is row 1, person 6, which comes up to Emma. Where's one place that you simplified?
I crossed out 5 log 5.
So these have the same base, and you're just left with this 7 here. So if we rewrite this, that's 5 times log base 4 of 64 to the 7th power. Okay, I need somebody else to help me simplify. Somebody else help me simplify. Let's see. Row 6, person 6. Michaela.
I put the 5 to 64 to the 7, so
Over there.
all the way across there. And then it's log 4 to 64.
Okay, so you then were able to multiply these two exponents together, so you got 64 to the 35th power. Okay, and there's one more thing we could do to simplify this a little bit more. 64 can be written as a base of 4 to the 3rd. So we have to the 3rd times that 35 there, or rather with 35. And if we have log base 4 and we have a 4 in our base of our argument, we can cancel them out, and all we are left with is y is equal to 3 times 35, which is 105. Okay. We have about 10 minutes left. I'm not going to make you learn a new thing in 10 minutes. So I'm going to give you your homework. Your homework is 4 problems, and these 4 problems have to do with the things that we were doing all day today. So if you are lost, these 10 minutes are a great time for you to start, find where you are lost, and ask questions. Okay? Homework starts on this page. On this page, I would like you to do this first problem. Oh, I don't think we ever actually... Actually, I want to do this first problem together. So we're going to do this first problem together, but it's also going to be assigned for homework, so you'll definitely have it done. I would like you to do 35, but do you see where the inequality is? The greater than or equal sign? Write it as an equal, please. We're not doing inequalities just yet. And on the second page, I would like you to do the first 2 problems as well. And again, wherever there's an inequality sign, just write an equals. And once you have selected those, come back to this first page. We are going to do this first problem together. I'm going to write it down here. We start with 3. Okay. This problem here, yes. Do we have the same base? No. Can we change one of these bases to become the other? No. If we can't do anything to either of the bases, and we have exponents that we need in both of them, what should we do to both sides? We should do a logarithm. Doesn't matter what logarithm we use. Will any help us? There are no logarithms that will help us here. I'm just going to use the natural log. Because it doesn't matter, because regardless of what you use, it's not going to help you much. So I'm going to use the natural log. And I'm going to say the natural log of 3 to the power of x minus 1 is equal to the natural log of 2 to the power of x. And from here, what can I then do? What do you think, Andrew? What do you think we can do next? I want to get these out. Yeah, we can put them in front. They were an exponent. Let's make them not an exponent. So you'll have x minus 1 times the natural log of 3 is equal to x times the natural log of 2. At this point, you could pull out your calculator and figure out what numbers are. On your test, you will be allowed a calculator. However, on some of the problems, they're going to tell you that they want this in exact form. And if it's exact, that means you can't have a decimal. So I want to solve this problem out without using any decimals. If I want all of my x values on one side, first let's get rid of one of these numerical values. So I'm going to get rid of this natural log of 3 first. If I get rid of the natural log of 3, I'll have x minus 1 is equal to x times the natural log of 2 over the natural log of 3. And if I just look at this, that's going to be a number, right? So this is a number. And since it's a number, that means that I'm going to end up with x minus 1 is equal to some number times x. And if I want to solve this algebraically, doesn't that mean I just need to move all of my x terms over to one side? So I'm going to say, okay, I have x here, and then I'm going to subtract it by whatever this number is times x. And that's subtracted by 1, and that'll equal 0. So if I continue solving this, I have x minus my number times x is equal to 1 because I added 1 to both sides. And from here, can I factor something out of my left-hand side? Can I factor out an x? If I factor out an x, what is left within my parentheses? I know that here this is going to be a minus number, whatever that number is. Is that just blank? What does it become? 1. So just because you factored out an x, you still have something remaining. And that is a 1. And that's equal to 1. So if I wanted x by itself, then I have to divide both sides by this 1 minus this number. And if I do that, I will end up with 1 divided by 1 minus this number. And what was that number? It was this thing?
No, I did log 3 over 1.
Okay, so it was this thing. And you could find the decimal for it, but again, they're asking for the exact answer in this case. And if they're asking for the exact answer, I would just put it right back how it was. So this was the natural log of 3, or was it 2? The natural log of 2 over the natural log of 3? 2 over 3, okay. I'm not going crazy. Good to know. And that would be my exact answer. If they just asked you to solve for what x is, and you just wanted to put in the decimal there, you can. You'll find some decimal for that on your calculator. So that's the first one. The other ones are going to be very similar. All your other problems are going to be very similar to the one that we just did. Maybe even a little bit easier, if you know the tricks. So you have the rest of the period, a few minutes, to work on those. Ask me if you have any questions about anything that we covered today already, or on the homework that you are currently doing. I'm going to stop the recording now because that is all there is for today.